Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your chemistry teacher for this session. If you're joining us for the first time, what we're doing here is we are going through kind of frequently asked problems in the secondary school level as well as in the university and college level. And what we're doing here is that we're going to verify some commonly asked problems in both chemistry and also mathematics. So what we're doing here is within the next hour, I have about 10 problems for us. I don't know if we'll get through all 10, but I'm going to do my best to do so, And what we're going to do is we're going to verify these solutions, and I'm going to kind of teach you the concepts through those questions as well. If you're tuning in for the first time, my name is Joey. I'm currently a Ontario school educator with OneClass, and my teachable subjects are chemistry, music, and as well as I'm hoping to I'll be able to teach math in about a month or so. So without further ado, let's get started on today's problems. I have about 10 problems for us today. All right, so the first question, I believe I've already finished this problem before, and it's kind of a repeat from maybe one of the streams from last time, but it's asking here, a solution containing a mixture of metal cations was treated with dilute HCl, and no precipitate was formed. Next, H2S was bubbled through the acidic solution, a precipitate was formed and was filtered off, then the pH was raised to about 8, and H2S was again bubbled through the solution, a precipitate again formed and was filtered off. Finally, the solution was treated with sodium carbonate solution, which resulted in no precipitation. Which metal ions were definitely present, and which were definitely absent, and which may or may not have been present in the original mixture. So let's look at the solution here, and these are the cations that they give you, these metal cations. And we can look at the solution here. So let me maximize this, let me zoom in for a little bit and see if we can kind of figure this out here. So it's asking here, so we have first, I like this graph because it actually breaks down all the possibilities of which all the cations may or may not exist. So it says here, aqueous mixture of cations here. If I have HCl and if it precipitates, if it doesn't if it doesn't go into solution, or if it forms precipitate with HCl, you're going to get either a silver, a lead, or mercury. And you can know this by simply just looking at a solubility chart. So let me Google that for you here, and you'll be given this on like a specific test or anything. And as you can see in Cl here, it's soluble except silver, mercury, and lead, and that's why they got here silver, mercury, and lead. And it forms a precipitate with chloride with all these three cations. Otherwise, it's soluble, right? So otherwise, it goes into solution here. If we're adding H2S, an acidic solution again, we're going to get these guys here are going to be insoluble here. These guys are going to create a precipitate because, as you can tell with sulfur here, it's insoluble except for group 1, 2, and NH4 here. So in this case here, these guys here are going to be like insoluble in water. Sorry, yes, insoluble in H2S here because it's an acidic solution. And then afterwards, we're going to add a basic condition here. Under a basic condition, a precipitate is going to be including these metals here. So aluminum, cobalt, iron, nickel, and manganese, and zinc would then precipitate and not be soluble in solution. And then finally, if we're adding sodium, I believe it says sodium carbonate here into our solution, we can see that in our solubility table, sodium carbonate would be insoluble except for group 1 and NH4. So group 1 would be barium. It would also be barium is group 2 here. So this is insoluble except group. This should be group 2 here. So maybe let's look at another solubility table to confirm the solution here. And I just want to see, nope. Let's look at these rules here. Let's look at carbonate. So this is CO3. Since their carbonates are frequently insoluble, group 2 carbonates are insoluble here. So this means that it precipitates out. So barium, calcium, magnesium, these are all group 2 metals. So as you can see in the periodic table, these are group 2 metals, right? Barium, calcium, magnesium, these are all group 2 metals, therefore they'll form a precipitate. And all the other metals are not the other metals will be in solution. So for example, sodium, potassium, and ammonium are going to be in solution. So the solution here is correct. I like how they broke down into specific steps here to kind of test your knowledge of solubility charts, but all you have to do is kind of go back to these rules and figure out which of these are soluble and insoluble in acidic or in basic conditions, and also with specific polyatomic anions such as carbonate, and also with such as carbonate. Yeah, that's about it. So this solution, therefore, is correct. So so the solution here is correct. Good analysis. I really like how they broke this down as well. It's a very detailed and very clear way of doing this.